Welcome to Lesson 3.3, Solving Equations. Today we're going to talk about how to solve addition, subtraction, multiplication, and division equations. Alright, so first we need to know what these words mean. So we have the inverse. The inverse means the opposite. So with numbers we know that the opposite number is, if it's a positive, the opposite is negative. So it's the same distance from zero but in a different direction. And then we also know that opposites can be found in many other things in life. So with opposites, yes, we can talk about the inverse of -4 is 4, and we've talked about these being additive inverses and how they get you to 0. That's going to be important coming up. And the inverse of red on the color wheel would be green. So inverse is another word for opposite. So then the inverse operation is operations that are opposite and that undo each other. So if you have addition, the inverse operation of addition is subtraction. So if you add 3 pieces of candy to your trick-or-treat bag, then to undo that, you would have to take away 3 pieces of candy from the trick-or-treat bag. Okay, so subtracting undoes any addition that you do, just like addition undoes any subtraction that you do. Okay, and then you also have multiplication and division that are inverse operations. And you also have squaring numbers and square rooting numbers. And there are plenty of other options that we have here, but just for now, we are going to really focus on these first two. All right, so looking at equations, so what you have to know is what that equal sign means. So equal should really help you remember that it's balanced. So if you were to put these two things on a scale, they would balance. They would be at the same level with each other. One would not be heavier than the other. So even though over here we have 7, since we have this equal sign, we know that this whole thing has to be equal to 7. And that's what this equation up here on top tells us, that 7 is equal to x plus 5, so something plus 5. Now, of course, you know by looking at this that x should be equal to 2, and we've talked about how we're going to have simple equations that we have to solve, but as time goes on, they're going to get more complicated, so make sure that you're practicing and putting in those steps to make sure that when things do get more complicated, that you're understanding what you need to be doing, so that way you can be most confident when you're putting together your equations and solving them. Okay, so we know that whatever x is, when you add it to 5, it has to give us 7 because it has to stay balanced with this side. Okay, that's what that equal sign tells us. So let's look at this in terms of a teeter-totter. So if you had a teeter-totter and you were saying that something plus 12 was equal to 45, that's what balanced your teeter-totter. Well, if you subtracted 12 from 45, that would make this side lighter than the side that you're adding 12 to. And that would cause your teeter-totter to not be balanced. And we always, with our equations, we always want our equation or our teeter-totter to be balanced. So then what would end up happening is you would still have x plus 12. Oops, don't know why that turned into a minus. You would still have x plus 12 over on the left, so you'd still be too heavy over here, but you'd be down 12 on this side, so you'd be too heavy for this side. Okay, so you'd be too heavy for what's going on over here. All right, so let's look at what this. So let's look at what this should look at like. So if you have x plus 12, what should be happening is you should be subtracting 12 from both sides. That means you're taking 12 away from this side and you're taking 12 away from this side. That's being equal. That's being fair in terms of your equation. So remember that golden rule of math, what you do to one side, you do to the other. We have to keep that in mind with our equations. So we subtract 12 from both sides, which when you do plus 12 minus 12, that ends up getting you to 0. So again, look at it with trick-or-treating. If you get 12 pieces of candy, but then you give away 12 pieces of candy, you end up with 0 pieces of candy. And then x plus 0, well, we know that anything plus 0 is itself. So that's how we get the variable all by itself, which is what we want when we're solving equations, and then we do 45 minus 12 and we get 33. And we're balanced because we subtracted 12 over here and we subtracted 12 over here. So we stayed the same on both sides. Then what you can do to check your work is you can say, okay, well, if I plug 33 in for x, does that give me 45? Well, 3 plus 1 is 4, 3 plus 2 is 5, and it works, so I know 33 is a correct answer. And x equals 33 actually is my correct answer. All right, so let's take a look at how this works. We're going to talk about how it works with inverse operations and with positives and negatives. So first, let's talk about positives and negatives. We know that we can change this to v plus a negative 10 equals 49 because we like to change subtraction to addition. And when I'm adding and subtracting in equations, what I want to do is I want to get to the point where I'm adding or subtracting by 0. Okay, and the reason that I want to be adding or subtracting by 0 is because I know that 0 does not change the value. It won't change the value of the variable. So I want to get the variable by itself. So v wants to be all alone. So in order for v to be all alone, we have to get rid of the negative 10, or in this case, the minus a positive 10, we know turns into plus a negative. So we want to get rid of that. So I know that to get negative 10 to 0, I have to add its additive inverse, or its opposite. Notice that word inverse pops back up again. And we know that the additive inverse is the opposite, so the opposite of negative 10 is positive 10. So I'm going to add positive 10 to both sides. Now negative 10 plus positive 10 I know gives me 0, so I end up with v plus 0 equals 59, because when I add that I get 59. And I know anything plus 0 stays the same, so I can go from v plus 0 to just v, because they mean the same thing. So v plus 0 is equal to v. That's why I can keep that. And then I keep the 59. Okay, so this is how it works out in terms of positives and negatives. And we definitely want to understand that, but maybe going back to subtracting might help us out a little bit. So if I have v minus 10 equals 49, I know that if I took away 10 pieces of candy from my sister's trick-or-treat bag, that I have to put 10 back in order to have it change 0. So if I want her amount of candy to not change at all, and I took out 10, then I have to put 10 back. So that means that I will have v minus 0, because subtracting 10 and then adding 10 undo each other. Okay, or you can think of a game board. If you go forward, or if you go, well, in this case, backward 10 spaces, to undo that and get back to where you were, you would have to go forward 10 spaces. Okay, look at a number line. If I'm at 0 and I subtract 10 and then add 10, I end up back at 0. Okay, but what I do to one side, I have to do to the other, so I get v minus 0 is 59. V minus 0 is always going to be v, so v is equal to 59. And if I go back and double check and do 59 minus 10, it gives me 49, so I know that this checks out. It works. So then with addition it's nice because it doesn't matter where the number is, like it will with subtraction. So with addition, I can do one of two things. Let's work with positives and negatives. Since this is a positive 28, I know that I would have to add a negative 28 to both sides, okay, because what I do to one side I have to do to the other. So that way the 28 and the negative 28 get you to 0 plus n equals, Well, I know 65 plus a negative, so I have two different signs. So 65 is my higher number, or my bigger absolute value. So I do 65 minus 28, and I get 37. And since 65 has the bigger absolute value, I know it's a positive 37. So I get 0 plus n, which I know is just n, so n is equal to 37. Now that's how this works if you're adding the opposite. That can get kind of tricky as we go along though, so let's look at it this way. I know that adding a negative is just the same as subtracting a positive. And since this is an addition equation, to undo adding 28, I would subtract 28. And what I do to one side, I do to the other. And notice that's exactly what I ended up doing here anyways. So here I end up with 0 because a positive 28 minus a positive 28 gets me back to 0. Plus n, well 65 minus 28 is still going to give me 37. And 0 plus n is still going to leave me with just n. So n is equal to 37. But now let's not just say, ooh, I got it, let's just leave it the way that it is. Let's double check our work and make sure that our answer is correct by putting the number back into the equation. So I have 28 plus 37 equals 65. I have 8 and 5 is 15, carry the 1. 2 and 3 is 5, plus 1 is 6. So I know that n equaling 37 checks out. Now I have a subtraction problem again, but the problem is, notice my variable is here this time instead of in front. This does create a problem. So what we're going to work on doing for the time being is we're going to work on getting p by itself, which might mean that we have to put it on the other side. Because if I add a negative 25, because I have to get rid of the 25 to get p by itself, okay, and to do that, I know that this is subtraction, but I'm not subtracting, so this turns into a negative p, not a negative 25. So I still have to get rid of the 25. Okay, so that still isn't going to help us out very much. So if I add 25 to both sides, I end up with 50 over here, and then I end up with more over here as well. And I still end up with this negative p. It doesn't give me 0, and I need this to be 0. All right, so let's take a look at how we can solve this without getting too complicated. So instead of messing with the 25, because I would have to subtract 25 from both sides, and that would give me a negative number. And if I do that, it will work out. So minus 25, because this is still the subtracting p, still makes this a negative p is equal to a negative 6, because that's what I get when I do 19 minus 25. But because p is negative, I'm going to multiply it by negative 1, multiply by negative 1, because what I do to one side I have to do to the other. So p should be equal to 6. Okay. This can be a bit confusing. So let's look at it a little bit less confusing and move the p to the other side. So if I add p to both sides, I get 25 minus 0 equals 19 plus p. Because all I did was get rid of it from this side and add it to this side. So I have 25 by itself is equal to 19 plus p, but I want p to be alone. I want p to be all by itself. Well, now I have this nice addition equation, so I can subtract 19 from both sides, and I get 6 on this side is equal to 0 plus p, which I know is just p. Okay, so it usually works out a little bit better when you're just learning how to solve equations to move that variable to the other side. Please remember that we are going to be practicing with this quite a bit, so if it's confusing, that's understandable, and it most likely will be, but you need to take your time and work through it, as we are going to see this a lot in the next couple of months and years with math. All right, so what about division and multiplication? With division and multiplication, we use the addition identity property. And we knew that for addition, we needed to get to 0. But for multiplication identity, it's not 0, it's 1. So when we are multiplying and dividing, if we want the variable to stay as it is, we need to get whatever we're multiplying or dividing by to 1. Okay, so let's look at it this way. Let's say that I know that 9 divided by 1 equals 9. So if I have v divided by 1, that should give me v. No matter what this variable is, it should still be v divided by 1 equals v. Q divided by 1 equals q. Whatever the variable is, it doesn't change the fact that when you divide it by 1, it stays the same. So keep this in mind as we're going along. Okay, so in this case, if I'm dividing by 10, to undo dividing by 10, I want to multiply by 10. And what I do to one side, I have to do to the other. So if I look at this in terms of a fraction, so dividing by 10, well, dividing by 10 is the same thing as multiplying by its reciprocal. When you multiply by the reciprocal, you get 1/10. And then if you're multiplying by 10, you know that becomes 10 over 1 is equal to 7 times 10. And here we turn into v times 1 equals 70. And I know v times 1 is going to give me v, which gives me 70. So you have to remember that dividing by a number is the same as multiplying by its reciprocal. That's what allows this to work. Okay? And dividing by 10 and multiplying by 10 undo each other. So let's look at 20. If I do 20 divided by 10 times 10, okay, I know that 20 divided by 10 gives me 2 times 10 gives me 20. So I started at 20 and then I ended at 20. So it keeps me at the same number. So if I did v divided by 10 times 10, it should be the same thing, that I would just get to v, or whatever I started with. Okay, so in this case, if I have 8 times a number, now addition or multiplication is like addition. It doesn't matter where it is, we can just move it around. So I can just, to get rid of multiplying by 8, I can multiply by the reciprocal. And what I do to one side, I have to do to the other. So I know that these two things cancel each other out, and I end up with 1, because multiplying, so the reciprocal should get a number to 1. And I know that 96 divided by 8 gives me 12, okay, because both of these, so this would be 1 and this would be 12, and that would be 12 over 1, so n would be equal to 12. Or I can say that I could do 8 times n equals 96, and I can divide both sides by 8, because dividing by 8 undoes multiplying by 8, and I still end up with 1 times n equals 12, and n would still equal 12. Again, put the number back into the equation to make sure that it works, and if you go back and check, 8 times 12 gives you 96. Okay, now here, this is where we have that crazy situation where it's moved around again. If you multiply both sides by 25 like we want to do, you're going to end up with 125, and you're going to say that 25 divided by 125 equals 5. Well, we know that that's not true, so we can't do that. So instead, let's multiply both sides by p, and get 25 divided by 1 equals 5 times p. 25 divided by 1 is 25 equals 5 times p. Then I can divide both sides by 5 and get that 5 is equal to p. Okay, again, I can go through the example of using the reciprocal, but at this point, we're going to be working with this enough so that if you do feel more comfortable using the reciprocal, you can absolutely do so. Otherwise, if you're understanding that these two operations undo each other and get to 1, because with the identity property for multiplication and division, we need to get to 1, then you're doing great. Right? So you have 6 problems to try here that all involve addition, subtraction, multiplication, and division. And you do notice that you have these problems, okay, here and here, where the variable comes second, so you need to take your time and always go back and make sure that your answer makes sense and that it works. As always, if you have any questions, please be sure to write them down or email me so we can go over them in class.